first exercise where we consider the area requirements for our building. We have here in the DOE typical office building, the architectural model for what we get. This is a 3-story office building, typical loads, typical layouts, and we're interested in understanding very quickly on how much area do we need in this building for our MEP, for our elevators, and for our egress stairs. If we turn our attention to the right, this is the Excel spreadsheet that we provided on the GitHub site and we're referring to. The user only has to input these three fields: the gross floor area for our building, the area per floor, and the floor-to-floor height. The spreadsheet automatically updates based on rules of thumb to help us understand how much area we need for the different components of our building system. You'll see that it's summarized here in these fields and broken up into the different components further below. So all the designer really has to do is take a look at these values, as well as the area requirements for the roof or any kind of central space, and model these within their space. And you'll see here, if we turn on this layer, you'll see the area requirement, the volume required for these different elements of the building system. Now, obviously, these have just been placed onto the model, and it would be the responsibility of the designer to allocate these spaces within the program somehow. Make sure that these line up in a place where we would have a riser, where we would have bathrooms, where we would have elevators. But the goal is, with very little information, basically just the GFA, we can get an estimate for how much area we need for our building systems. And this is an important first step for designers to understand the magnitude of the area requirements for these systems, as well as understand how to put them within the space. Okay. So this is intended to be a first order estimate, very easy to use without requiring further modeling or further analysis work.